You are welcome to this class on the analysis of 2023 Physics JAMB questions, okay? We are going to look at all the 40 questions, analysis and solutions, okay? Please don't forget to drop your likes and comments. Also share this video with your friends and your loved one, okay? Let's look at this first question. It says what? What is the force on a segment of wire that is 0.5 meter long and has a current of 2 amp when placed in a magnetic field of 2,3 at an angle of 30 degrees to the field? For this kind of question, they want you to recall the formula for magnetic force, okay? That formula is actually like this because it's a vector quantity. It has direction, okay? Also, it's current multiplied by length. The length too has what? Has direction. Multiplied by this, okay? Which is the magnetic field. If you want to use it to calculate the magnitude, because the question is asking us to get the value, to get the magnitude, all you have to say, you say F is equals to this sine theta. So all you have to do now is to substitute. We are given this to be 2, the length to be 0.5. Okay. This is given to be 2, that is magnetic field. 2 sine 30. What is sine 30? Sine 30 is 0.5. That is 1 over 2. Okay? If you multiply this, you're going to get 1. If you multiply this, you're going to get 1. It means if you multiply this now, everything is 1. Okay? That is 1 Newton. So the answer is this. Okay? This question, very important question. It says the mode of heat transfer that is electromagnetic in nature is what? That is, it doesn't require any physical material to transfer the heat. The answer is simply radiation. Another question says what? The condition for resonance to occur in an RSC series circuit is what? It says when the angular frequency of the applied voltage is equal to the natural angular frequency of the circuit. I don't want to go for that. A is the answer. Look at this question. It says what? A solid weighs 10.5 Newton in air and 5.5 Newton when a mass in a liquid of density 900 kg per meter cube. Calculate the volume of the solid when G is equal to 10 meter per second square. Look at this. An object is in air. In air. This is the weight in air. When you immerse it in water, you measure the weight, that is water, sorry. When you put it inside water, it has another weight that is less than this. What is going on? It is because of upthrust. The water is exerting a force on it. When the object displays water, the volume it displays is used in assisting to lift the object up in a little way. Not actually equals to this total, but it assisting it to reduce the weight of the object. That is why objects in water, they have lesser weight than when they are outside water or outside a liquid. We are asked to calculate what? The volume. So what we're going to do now is that to know that what? This force that is helping us, the upthrust, okay, is equals to the weight in air when it's outside water minus when it is inside the water, which is equals to, as you can see here, this is outside water, inside water. That is 10.5 Newton minus 5.5 Newton. To subtract this, you agree with me, you're going to have 5 Newton. This is the upthrust. We are not looking for the upthrust. Another way to calculate this same upthrust. So, say this is upthrust, is to say that the density, this is the density, multiplied by the volume, multiplied by G. This another way. It's like you have two names. Your name is James. You can also be called or depends on where you come from. So it means James is equals to. So this is James. This is. So we can equate these two together by saying this is equals to this. By saying 5 Newton is equals to this, because we already have it calculated before now. All we are looking for is the volume. So volume here now is 5 over this and this. What is this? Is what is given to us to be 900. That is 900. Why this is 10. This is equals to 5 over 9,000. So once you calculate this now, you get 5.56 times 10 to the power minus 4 in meter cube. That is B. B is our answer here. Let's look at this question. If you don't want to be JAMB customers, you have to pay attention. A uniform meter rule, that is an information to let you know that what? The weight of the rule is evenly distributed. Meaning, if I have this weight, if I have this meter, that is the rule, the one we call ruler, it means the center is where the center of gravity of this weight is located. That is where the weight of the body will be exerted. It means the weight of this guy will be here, the weight of the ruler. And it is AB. These are important details. It's balanced at a knife edge, 60 centimeters from B. So if here is 50, somewhere here to here is 0, here is 100. Now, from B, as you go back here, around here, 60 from B, that is where we put this knife edge. It means from here to here is 60. Also, from here to here, definitely, you agree with me, it's going to be what? 40. Because 40 plus 60 will give us 100. Now, when a load of 22G is kept at 10 centimeters from A, 10 centimeters is somewhere here. Let's say this is 10. So a weight is placed here. It is 22 grams. Okay? You will agree with me, if here to here is 40, here to here is 10, here to here will be what? 30. So if here to here is 60, here to here is 50, here to here will be 10. All the information are ready. What is the weight of the meter rule? The weight of the meter rule is this. All you have to do is the clockwise force is equal to the anti-clockwise force. The moment at this point, clockwise equals to that of anti-clockwise. What that means is this 22 multiplied by this before the knife edge is equal to this weight multiplied by this before the knife edge. Divide both sides by 10. You agree with me? W therefore is equal to 22 times 3, which is 66 in gram. 66 gram. So as you can see, C is the answer for this question. Don't miss it. What is important here is just the analysis. To know where to put the right what? The right weight and how to subtract effectively. This one at the clockwise, clockwise is not anything. That's simple. They want to confuse you to understand, to really check if you understand what you are doing. And remember, you have to solve this very fast. Okay? Look at this question. If you have been following me, you will see that there are a lot of repetitions. This is also a repeated question because they are saying a particle in a simple harmonic motion while passing through mean position, we have minimum kinetic energy and maximum potential energy. With this, I will stop. I'm not saying A is the answer. I'm not saying A is not the answer. I need to remember this harmonic motion. in simple pendulum, this is the mean position. That is the mean position. The height here is always equal to 0. Remember, it's swinging. So when it is somewhere here, you will agree with me that if I draw a line here, the height between this and this position is very high. Also, when it is somewhere here, the same thing. So the height here is high. I remember when it's here, it stops. And then stop, stop. Why in this position, or why at this position, the potential energy is very high? Because potential energy is the energy you have when you are at rest. But the kinetic energy is 0. The same thing with this position. But here, the kinetic energy is very high. Why? Because at this position, it's swinging through. This is the place where it has the highest velocity. I here is 0 because h here is 0, the height is 0. So when the potential energy is 0, kinetic energy is the highest. It means it converted potential energy to kinetic energy. But the potential energy here, that potential energy here, is 0 at this position. So let's look at this information. Minimum kinetic, I say no, not minimum kinetic. Maximum potential at never. Potential is 0. Minimum kinetic is a lie. Maximum kinetic, very true. Minimum potential, exactly. So D is the answer. Okay? D is the answer. Let's look at this. It says what? A pin floats on water due to the phenomenon of what? If you are reading your books, you agree with me, you don't need to think here. This is the answer. We have done something like this in one of the years. Check the videos, you will see something like this. But that one was asking us when the tension on the surface is high. But this one is asking us why is the pin floating? When the surface tension of liquid is high, definitely you can place a pin on top of the liquid. It means the tension on the surface is high. But if the tension is low, there is no way it can what? It can hold a pin. Like the water, you are boiling water. You put a pin to enter inside because the molecules are at maximum energy. They are just vibrating. They are giving a lot of space. But here, assume it's cold. They will construct all the particles coming together, forming alliance. And when you put something, it can't easily penetrate. That is the surface tension. Depends on if it's going to float or not. Okay? Let's look at this. It says what? Something, we don't know the thing. It converts electrical energy into mechanical energy. Okay? 2, it generates electricity. 3, it is based on the principle of electromagnetic induction. 4, it follows Fleming's left-hand rule. Which of the statements above is or are true for electric motor? Oh, they are asking us about electric motor. So let's analyze each of them. Let's do it like this line. Electric motor converts electrical energy into mechanical energy. Of course, if you go and grind pepper, you have to pull the plug and use electricity to run the motor to grind your pepper. The turning of the motor is mechanical, but it's electrical energy that is coming to the motor to cause it to rotate. Therefore, A is very correct for electric motor. 2, it generates energy. No, electric motor does not generate energy. That is, does not generate electric energy or electricity. This function is performed by generator. You agree with me in your house. When you want to assume you don't have energy from the power grid, you on your generator, what is it going to do for you? It's converting mechanical energy to electrical energy. Okay? What it's doing for you is generating you what? Electricity. So this is not correct. You are not correct. 3, it is based on the principle of electromagnetic induction. This is also false. While electromagnetic induction is a principle underlying generators and transformers, electric motor force is on the principle of interaction between magnetic field and electric carrying conductor to generate force. So this is not correct. Lastly, it follows Fleming's left-hand rule. Correct. This is true for electric motor. Therefore, this is the answer. Okay? Let's look at this. So, it says what? A thick glass tumbler cracks when hot water is poured into it. Because of what? A, anomalous expansion of water. B, uneven expansion of the glass tumbler. I'm coming. C, thermal expansion of water. D, even expansion of the glass tumbler. Actually, this is the answer. Why is it the answer? Let's say this is a tumbler. Okay. This is the internal surface, this is external surface. You pour hot water. Yes. Plenty hot water now. What do you think will happen? The internal molecules of this glass, we acquire it from the hot water. In the process of acquiring it, they will be expanding. Remember, the heat that is being absorbed is not getting outside yet. Outside is still colder than inside. The inside is hotter than outside. It means the expansion that is being experienced by the internal surface is not experienced by what? The external surface. It means there's an uneven expansion because one is acquiring it, that's making it to expand. The other guy on the outside is just as if he doesn't know what is going on. Because of that uneven, one is expanding, one is not expanding, or later one is expanding more than one, it will create a crack and break the bottle. So this is the answer. Let's look at this. It says what? Which of the following is the function of a PN junction diode of a semiconductor device? What is this? You need to first of all understand this. What is it all about, this diode? Diode, they work like rectifiers. What is the work of rectifiers? In this is they convert AC to DC. That is what it's meant to do. So let's read now. It can be used to convert alternate current to direct current. So we already have the answer. All this other one, direct to alternate, no. It can be used to amplify, no. It can be used, no. A is the answer. Okay? A is the answer. That is the work. It works like what? A rectifier. This is because the diode allows current to flow only in one direction, effectively blocking the opposite direction of flow. It blocks the what? The opposite direction of flow. Okay? We are talking about, this is the way we represent it in say PN. Okay? This is actually the positive end, positive, and this is the negative end. Okay? So it allows what? The movement of flowing of current in one direction. So it converts AC to DC, blocking the other end. Okay? Let's look at this. It says what? Which of the following is true for a particle in a stable equilibrium. When anything is in equilibrium, it means that it's at rest. Sometimes it can be turning, but that turning is constant. Okay? Depends on what you are looking at. The first one says potential energy is constant at all. Potential energy is maximum at all. Potential energy is minimal. Potential energy is zero. No. When you are looking at zero for something in equilibrium, we are looking at what? The resultant force. The resultant force is zero. But this one, we are talking about the potential energy is minimal. Of course, it's minimal. Look at this. It says what? Determine the equivalent capacitance of the capacitors shown in the circuit. When we are talking about capacitance, it's different from resistors. That is capacitor. This is what? 3 microfarad, 1 microfarad, and 2 microfarad. When resistors are in parallel, you do what? You say 1 over R equals to 1 over R1 plus 1 over R2, and so on and so forth. But when they are in series, you add them together. For capacitor, it is the opposite. When they are parallel, this is parallel connection because you are joining two things like this. This end and this end are joined together because this is one, this is the second one. You are joining this end, you are also joining this end. It means these two, they are parallel. So because they are parallel now, as far as capacitors are concerned, you add them together to get the what? The effective capacitance. It means these two guys, they are going to produce for us 3 microfarad plus 1 microfarad, which is equal to 4 microfarad. So it means we can redraw this again now to have this. Okay? Why now? This is 4. So this is now 4 microfarad. Why this is 2 microfarad. Now they are in series. One hand is connected to the other hand just like that. In series. When they are in series, you look at them as if they are resistors in parallel. Therefore, you say to get the effective capacitance is 1 over 4 plus 1 over 2. This 4, this 1, this is 2. That is 3 over 4. Okay? It means therefore 1 over this 3 over 4. And to get C now, you turn this to have 4 over 3. If you divide, you have 1.33, and so on and so forth. That is the effective capacitance. So you can see D is the answer. Okay? Hope you are getting this. Let's look at this. It says what? The power factor of a series RLC circuit at resonance is what? The power factor of this at resonance is simply equal to cos 0. Cos 0. And cos 0 is 1. So the answer is B. No need to waste our time. Let's look at this. It says what? In the given circuit, what is the ammeter reading given that the voltages across capacitor and inductor are 300 volt each. Here to here is 300. Here to here is also 300. One thing you know is that when it comes to capacitor and inductor, you have to subtract their voltages. They will negate themselves. So actually, the effective voltage here, that is the potential difference across this, is actually this one, that is the total across all of them, that is this, as equal to the square root of the one across this, let's call it VR plus these two. This, let's call this one VC minus VI. All square. This square, this is square. Okay? Okay, let me remove this square. This one, let me remove this so that you understand what I'm talking about. So this is square. The square of this total, because this is the PD across everything. The PD across everything is 220. Is equals to this plus this group. This group, you have to subtract them. You agree with me? To subtract them, it's already 0. Why this is what? For the R. This is actually gone. You agree with me that this square, this and this will cancel. So VR is actually this. If you know what you are doing, you don't need to solve this. Just simply this divided by this, you get your answer. Okay, now that we know that this VR is 220, it needs therefore to get R, which is this, is equals to 220 over, that is the voltage across this, over 100. And you agree with me, if you divide this, you're going to have 2.2 in amps. Okay, so the answer here is B. Let's look at this. It says what? One of these is not an example of a mechanical wave. Mechanical wave, they require a medium to what? To flow or to transport them. Just like water, you see wave on top of water. The water is assisting the wave to move. So one of them is not mechanical. Sound is mechanical. It requires air. Water is mechanical. Light is not mechanical. This one, seismic, is mechanical. So therefore, our answer is C. Very straightforward, okay? Another question. It says what? Which of the following is a scalar quantity? Electric potential, definitely electric potential. Look at this. It says given 3 capacitors, each of capacitor C. The resultant capacitors of this can be obtained by doing what? 3 capacitors are given to us. 3 capacitors, capacitance, capacitance. 3. We are asked to form this. What can give us this? Say combine all of them in parallel. Parallel, that is, this is where all of them are in parallel, you add them together to give us 3C. It's not possible. This is out of it. Connect all of them in series. If they are in series, it's 1 over this plus 1 over this plus 1 over this. If you solve this now, you're going to have C, 1 plus 1 equals to 3 over C. So this is 1 over C resultant. To get this now, you say equals to C over 3. This is not C over 3, so this is out of it. Okay? Let's continue the analysis. Another one says 2 in series. If 2 are in series, let's say these 2 are in series, you do 1 over this plus 1 over this. That is this, 1 plus this, equals to 2 over C. Then you turn it upside down to have C over 2. That is the effective resistance for 2. Then this one is now joined to them to be in parallel. To be in parallel, simply add it to it. 2C plus 2C. That is 3C over 2. 3C over 2. Again, this is wrong. The next one is 2 in parallel, third one in series. So let's say these are in parallel. If they are in parallel, it's C plus C equals to 2C. In series with this now, that this one is series with this, it means you have to do 1 over 2C plus 1 over C, 2C, that is 1 plus 2 equals to 3 over 2C. To get, you turn it upside down to get the final one. 2 over 3C. 2 over, yeah, exactly. So this is the answer. Let's look at this question. It says what? If 2 plane mirrors are positioned side by side, the number of images formed is 8. At what angle are they positioned? For you to get 8, they must have been positioned at an angle. To get this, we use the formula that says n is equals to 360 over theta minus 1. This is the number of images formed. This is the angle we are talking about. So now we put 8 here, we put 360, we put theta, we put minus 1. Now we are looking for this. We move this to this side. We have 9 equals to 360 over theta. You agree with me? Theta, therefore, is equals to 360 over 9, which is 40 degrees. You divide this. So the answer here is B. Okay? B is the answer. Let's look at this. It says what? The half-life of a particle is 4.5 days. How long will it take 3 over 4 of its original mass? How long will it take this? Okay? So Let's assume that the original is 1 gram. Okay? Now what is remaining now is this 3 over 4. We do this 4 minus 3 equals to 1 over 4. What it means is, when 1 gram is given to us, the original, half of this we guess to, that is 1 over 2. Another half of this is 1 over 4. What it means is, we are given this, half of it decayed, remains half decayed again, remains 1 over 4. To move from here to here, we are told that it's 4.5 days. To move again for another half is 4.5 days. What is the total? Because you agree with me that if this is what is remaining, it means that this is what is gone. That is 1 minus 1 over 4. 4 minus 1 equals to 3 over 4. This is what is gone. So if you add this from here to here, is 9 days. A is the answer. Don't know if you understand me. To get here, 4.5 days. To get here, 4.5 days again. Then you add the two together to get the total. 9 days. Okay? Let's look at this. It says a transformer core is laminated to reduce what? So the answer is eddy current loss. Because if you do not laminate the transformer, there is what we call the eddy current loss. These losses are induced due to alternating magnetic field. So because of that now, there will be losses. So we need to laminate the transformer to reduce these losses. Although the losses will be there, the lamination will reduce the losses. Okay? Let's look at this. A glass rod is charged when rubbed with silk cloth is because it transfers negative charges. This is actually the answer. When you rub this glass rod with silk cloth, it transfers negative charges here. Itself will acquire positive charges. So A is the answer without wasting time. Okay? Let's look at this. It says what? Addition of prevalent impurity to semiconductor A increases the number of holes. Now that we know where the answer is going to, let's analyze. When you add prevalent impurity to a semiconductor, it is meant to create more holes in the structure of the semiconductor. To create more holes in the structure of what? Of the semiconductor. So A is the answer. Okay? Let's look at this question. It says what? A charge of magnitude this is placed in a uniform electric field of intensity this. Calculate its acceleration if the mass of the charge is this. Calculate the acceleration. We have to use this formula that says F is equals to the charge multiplied by what? Electric field intensity. Okay? The force on the charge is equals to the charge multiplied by the electric field intensity. Okay? Electric field intensity. You will also agree with me that F is also equals to ma. Why am I bringing this? Because they are talking about acceleration. Okay? They are talking about what? Acceleration. And as you can see here, we are not given any force. All we can do is to equate this because they are equal now. So therefore, we can say this is equals to ma. We are looking for A. A therefore is this over m. Okay, now what we need to do now to move forward, we need to substitute here. Okay, let me push this here so you can see what we are doing. A is equals to, what is the charge? The charge is 1.6 multiplied by 10 raised to the power minus 19. What is the electric field? It's 1,200. What about the mass? The mass is 9.1 times 10 raised to the power minus 21. We solve this. To solve this now, you agree with me that we can do something very sharp. we are going to say 1.6 times this 1,200 all over this 9.1, so that we can use indices to crush these guys, this one, okay? That is to say 10 now, say this 90 minus 31, okay? This is 1.6. I don't want to disturb myself here on this because I want to finish with this guy. So this will give us 10 raised to power. This is plus now, minus minus. That is, you're going to get 12, okay? You're going to get 12. Using a calculator, let's get this other one. Let's get this other one. That is 1.6 multiplied by 1,200 divided by 9.1. Going to get here 210.99 times 10 raised to power 12, okay? Now, you agree with me? If you look at the answer, they are all in one decimal place. So, this becomes 2.11. We move 2 of this, I increase this to 14. So, therefore, this is the answer. So, you can see, even this first one, see the way they position 12 here, they want you to be their customer, okay? They know that some people will not do this last movement we did here. They will simply look at the answer I put. Then you are wrong. So the answer is B. Let's look at this. It says what? The fundamental frequency of an open organ pipe is the same as that of the second octave of a closed organ pipe of length 0.2 meter. What is the length of the open organ pipe? This question is using some terms here to see if you understand the meaning of open organ, second octave, and so on and so forth. So that is the first thing we are going to deal with now, because this might not be the exact question you'll be asked. So why not first of all understand the meaning of all these jargons? The fundamental tone you will ever get in a closed organ, when we talk about closed organ, the fundamental tone is always like this. Say this is closed. Okay, this is rough. Okay, this is the length we are talking about. We talk about first overtone. If you are told first overtone, you do this diagram like this. Let me make it smaller, please. Bear with me. It's like this. Okay? This is what? First overtone. This is fundamental tone. This is first overtone. The second overtone is like this. Second overtone. It's like this. Okay, let me make it like this. If I get it right. 1, 2, 3, like this. Come back like this. So you can see how many do we have? We have 3 here. It shouldn't be like this. It's like this. It should be like this. Okay. That is 1. What I'm trying to draw, I don't know if you can see it because this is too rough. Touch here, come down, come here, touch here, just like this. This is what the second overtone. Second overtone. So the question is talking about this, about second overtone for what? For a closed organ, because this is closed here. So we are going to keep this, okay? It also told us that for the open one, same as say the fundamental frequency of open one. This is for closed one. For open one, the fundamental is like this. It's simply like this. This is what? For open. The fundamental frequency. So we are saying that this, the length of this, is equal to the length of this. This for closed, this for open. Okay? Now, we are asked to calculate the length of the open. We don't know this length. This was given to us to be 0.2. Okay? So now, we need to understand the wavelength. The wavelength of this. What is that? This you are seeing here, this here is simply what? 1/4. You can say is quarter of a wavelength. 1, 2. That is here alone is 1 plus this is 2. 3. That is here. Okay, let me just put it here. For here to here, this place alone is this. Okay? For this one, there are 2. For this, there are 3. Ow. Here, 1, 2, 3. Let's come for this. That is 1, 2, 3, 4, 5. 5/4 is for this. For closed organ. Okay? That's how to calculate it. 1, 2, 3, 4, 5/4. If it was only this now, this is simply 1. That is this. That is this over 4. So with this information now, you will agree with me for this one that was given to us, for the second overtone that was given to us, we have the wavelength now. And we know the length to be what? To be 0.2. It means 0.2 is equals to 5/4 this. Then we find this to be 0.2 times 4/5, which is 0.8/5. You're going to have 0.16, okay? 0.16 in meter. We are going to use for this side too. That is this wavelength. So remember, these are just for illustration purpose. Let me remove this so that it will not confuse you again. Okay? This is for open, this is for close. We know this to be 0.2. We have equated this to this. Then we solve this. Now let's go for this. How many are you seeing here? 1, 2. That is 2/4 this. That is 1, 2. That is over this. Okay? And that is the length we are looking for. That is this length is equal to this. That is this is equal to this. Remember, for this side, we also do the same thing. The length is equal to this. Okay? This one we have calculated now is actually, let me write it. It's actually 2/4 this. 1, 2/4 this as equal to also the length. The way this was also equal to this length. It means, therefore, we already know this already because they are the same, 0.16. All we need to do now is to find here to be 2 times 0.16/4. Here 1, here 2. If you do this now, you're going to have 0.08 in meter. So therefore, the answer is D. D is the answer. Okay? Let's look at this. It says, what is the maximum possible wavelength of an open organ pipe of length 8 centimeter? Open organ. This is 1, 2. That is 2 altogether. 2 altogether. 1, 2. 2/4 wavelength as equals to the length. We are told the length is A. The length is A. You agree with me if you cancel here? That is 1/2 equals to A. So the wavelength, therefore, is 2A. That is cross multiply. B is the answer. Okay? Let's look at this. It says what? Mercury is used as a thermometric substance because 1, its specific heat is low. 2, it does not wet glass. 3, it is opaque. This means what? It requires less heat to change its temperature. And these characteristics make it very sensitive. For instance, they want to measure your temperature and your body is transferring little heat to the instrument. The substance they are going to use to design the instrument should be the one that with little heat, it will change its temperature. So A is the answer. For B, it does not wet glass. Of course, mercury does not wet glass. This and this are correct. It is opaque. Of course, it is opaque. So with this now, it means that you can easily read it. You can see the mercury going up. You can see it. It's not transparent. Okay? So it means all of them are correct. So this is the answer. Let's look at this. It says the effect of the eye lens, which occurs when the ciliary muscles are weak, is called what? It's called presbyopia. Let's look at this. It says what? A light of 6.22 eV is incident on a cadmium surface if a stopping voltage of 2.15 eV is required to reduce the photoelectron to zero. Calculate the work function of the cadmium in electron volts. This kind of question requires us to use the photoelectric equation that says the maximum kinetic energy is always equals to HV minus the work function. What is this all about? This is the energy of the incident light, the energy of the incident light. Okay? So to get this work function, we simply do this come here, this come here. Maximum kinetic energy. Okay? As you can see, this maximum kinetic energy is actually equals to EV. Okay? It's equals to EV. And the EV here is, that is the stopping voltage, is 2.15 EV. So what we simply need to do is to substitute here the 6.22 minus 2.15. If you subtract this now, you agree with me, you're going to have 4.07 EV. So this is the answer, that is A. Let's look at this question. It says, a gun with a muzzle velocity of 500 meters per second shoots a bullet at a bird 50 meters away. To hit the target, the gun should be aimed at what? When you do a gun like this, it means it was horizontal movement. Okay? And you agree with me that if this was the position, it means the bullet, as it was going here, it will definitely be dragged down by gravitational force. So the direction of this will be like this, okay? To fall to the ground. The bird is somewhere 50 meters away. You will also agree with me that this is the height. Like this. This is the height. Okay, let's say h. We know that this is equals to ut plus 1 over 2 at squared, right? Which you can now write as this for vertical, gt squared. Now, because it's horizontal, it means we cannot use this for vertical because everything here is now vertical. So this becomes what? 0, because the initial velocity. 1 over 2 times 10, because we are given 10 here, times t. You agree with me that velocity is actually this over time. So time is, okay? So now we know the distance to be 50. That is 50 over v. V is given to be 500. Okay, that means we are going to get 0.1 seconds. So here we're going to put 0.1 square. Okay, we are getting the time from this and this. Now with this information now, you agree with me, is 1 over 2, which is, put here is 5. 5 times 0.1 times 0.1. Okay, this will give us 5 times 0.01, which is 0.05 meter. But the answers are talking about centimeter. Multiply this one by 100, that is 5 centimeter. Okay, so the answer is 5 centimeter. So A is the answer. 5 meters high above the ground. Let's look at this. It says If the distance between two suspended masses, 500 kg each, is quadrupled, the gravitational force of attraction between them is what? You agree with me? The formula is F is equals to this m1 m2 over r squared. Okay? But now, we are told that this distance is what? Quadrupled. It means, therefore, we are going to replace this r, that is the new force now, let me call it like this. The new force, we are going to, because this one still remained the same, this was the only thing that was increased, 4 times the original. If you solve this now, you agree with me, you're going to have g this over 60 r raised to power 2. The new force we are looking for is, you have to say 1 over 16 to bring it out. So this is the old force. This one is the old one. So that is the one we had before here. I can replace this now by the 16 by F. So the new force is 1 over 60 of the old force. Okay? Reduced, because we are dividing it, reduced by 16. So D is the answer. Okay? In a simple machine, the variation of the efficiency with load is what? Is simply parabola. Parabola. Okay? Binding energy is the amount of energy released when protons change energy level. No? The amount of energy released when electrons change energy levels. No? The amount of energy required to break a nucleus apart into protons and neutrons. So C is the answer without wasting time. Let's look at it. It says if the heat capacity of 100 grams of substance is 300, what would be the heat capacity of 10 grams of the substance? This is not specific heat capacity. We are talking about the heat capacity, the amount of energy. All you have to do, we are saying 100 grams will give you this. How many will 10 grams give to you? Every 100 we have this. To get for 1 gram, we say 300 divided by 100 equals to 3 to get for 1 gram. Okay? So, to get for this now, because we now know this constant is 3 times 10, which is 30. So, A is the answer. Okay? This is very trickish because some people will mark 300. This is not asking us for specific heat capacity. Specific heat capacity of any substance, irrespective of the quantity, doesn't matter. It's the same throughout. But this one is talking about the heat capacity, the amount it will hold. Okay? The quantity of heat it will carry. Okay? Woody ladles are commonly used domestically to scoop or soup because of is a good insulator of electricity out of it. We are not talking about electricity where you are considering turning soup. B, good insulation of heat and electricity. This one has spoiled it, the electricity. Bad conduction of heat. Bad conduction of heat. Good insulation of heat. So the answer is D, good insulation of heat. So this is the answer. Let's look at this. It says, which of the following thermometers uses the volume of a fixed mass of liquid as its thermometric property? Simply mercury. So anyway, I see mercury here. Mercury in glass thermometer, okay? As pressure is increased, A, the melting point of the ice decreases. B, the melting point of the ice increases. C, the boiling point of the water increases. D, no change is observed in the melting point of ice and the boiling point of water. As pressure increases, the melting point of ice decreases. The melting point decreases. the amount of it you need to melt the ice, will it increase or decrease when you increase the pressure? You agree with me, like pressure cooker. The purpose of the pressure cooker is to increase the pressure. It means A is the answer. The melting point of the ice decreases. Although I use water to make you understand because of pressure cooker, but here we are talking about ice. This is the answer A, okay? Which of the following statements about gamma ray is or are true? It carries a negative charge. No, it doesn't. It can be deflected by both magnetic and electric field. No. It can be stored by sheet of paper. It has zero net. This is net, please. Net. Net mass. This is net. And a neutral charge. So therefore, this is the answer. Okay? A cyclic of mass 30 kg exerts a force of 250 Newton to move its bicycle. A cyclic of mass 30 kg exerts a force of 250 Newton to move its bicycle. The acceleration produced is 4 meters per second square. What is the frictional force between the road and tires? Okay? The frictional force between the road and tire. See, this is the road, this is a tire, okay? Sorry, this is a tire. The frictional force between the road. Okay, as you can see, mass is given to us to be 30 grams. What is given to us again is the force is 250 Newton. Another information we have here is the acceleration. Acceleration is given to us to be 4 meters per second square. Okay, and you will agree with me that F is equal to ma. This is the force you are applying. Mass times acceleration. Remember, there is an opposition. That is what? The friction that is opposing this force. So F minus the friction is equals to ma. Is the remaining one you are going to use to push it. Okay? So if I move this to this side, I move this to this side. Friction, therefore, or frictional force equals to F minus ma. That is this F, capital letter F. Okay? We know this to be 250 minus this to 30. 30, is it gram? I put gram. It's supposed to be kg. So sorry, this is kg. Otherwise, I would have converted it. 30 times the acceleration is 4. So this is 250 now. This is what? 120. If you subtract, it's going to have 130 Newton. 130 Newton is the answer, okay? So B is the answer, okay? Look at this. The temperature of land rises more quickly than that of sea because the specific heat of the soil is more than that of water, less than that of water, equal to that of water, negligible. The specific heat capacity of land is lower than that of water. That is the reason why it will heat up fast than water. The temperature of land rises more quickly. If your specific heat capacity is low, it means to heat you up is very easy. But if it is very high, like iron, it means to heat you up require a lot of what? Heat energy. So the answer is less than that of water. B is the answer. Finally, we have finished the class. Please, if you have not subscribed, subscribe. If you have not shared this video, share it. If you have any question, drop it in the comment section. Thank you so much for staying by to the end of this video. I wish you success. Thank you.